Welcome to this BITS Academy on Cycling Data, co-hosted by Cycling Industries Europe and the University of Oldenburg. I'd like to invite our colleague, Johannes Schering, to give us introductory words from the University of Oldenburg. Johannes.
Yeah, okay, let's start. I will share my screen now. Do you see the slides? Can you see the slides?
We do.
Okay, I make a full screen. Yeah, hello everybody. It's great to have you here. Big interest in the event. Best greetings of our professor, Jorge Max Gomez. He's our leading professor of business informatics at the University of Oldenburg. Unfortunately, he got sick this week. So I will take over the introduction in his name. Best greetings to all of you. Thank you for participation. We will show you some very interesting results on European cycling data today in cooperation with Cycling Industries Europe as part of the BITS project. Yeah, our motivation is, as we all know, there's big interest in cycling solutions now. So we have great infrastructure projects in the Netherlands and Belgium. So here you see some very interesting examples. The biggest bicycle parking facility at the Utrecht Central Station, more than 12,000 parking spots we have here, so it's very impressive. And the Hovenring, the picture below, is also very interesting infrastructure project from the Netherlands, close to Eindhoven. It's a roundabout where the people can cycle above the main road. And a very new project is also the roundabout at the right side. You see it was opened in 2020 in the province of Utrecht, in Veenendaal, Fietsstad, bicycle capital of Netherlands, in the province of Utrecht last year, similar to the roundabout in Zwolle. Very interesting projects. So we see that there's now big interest in these cycling projects, infrastructure projects. The promotion of cycling has huge potentials to solve traffic problems, to make cities more sustainable, more attractive, let the people cycling to work instead of using a car. And so governments are more and more interested to spend money for improvement, spend funding in the bicycle infrastructure. So German government confirmed that they will invest to 1.4 billion euros in the next 3 years in infrastructure. The city of Paris will work on a new cycling network, similar to the metropolitan network. They have 500 million euros they will invest. Germany is also investing in bicycle professorships. So 7 universities or universities of applied science have new professorships specializing on cycling. And yeah, to make good investments in the infrastructure, to do the right things, new knowledge about the needs and the requirements of cyclists are necessary. We need more data, more knowledge about what are the cyclists are looking for, what are their requirements. And the problem is that cycling data is often not available or not accessible. So we found some open data sets as of the city of Munich or city of Bonn was already publishing their bicycle countings on open data portals, mostly local open data portals, but it's quite hard to find, and there's no spot where I can find all these data, make all these cities comparable. And we also learned that these data sets are not really comparable because there's no collaboration. So our department is working on several cycling projects for about 2 years. So the BITS project details will be introduced by Kevin Main. So here we will work on an open data portal for cycling data. Province of Antwerp will introduce to the cycling data hub later. We have many implementations, sensors, near accidents, bicycle apps, and so on. We're also working on smart bicycle helmets, as like helmets could be a good opportunity, good option to assist bicycle couriers on their working process, to help them to work more efficiently, to get information about their parcels on an augmented reality glass. This will be introduced by a short video and also by UVEX Sports later. And we're also working on bicycle sensor projects. So the sniffer bike project will be presented. We also worked on this kind of sensor boxes. So cyclists are very interested, very willing to participate, spending their data to support the municipalities on their path to a more bicycle-friendly city. Yeah, there's big interest, and especially in the Corona time, we see that the bicycle is really a winner. So people avoiding public transport and switching to their private car or switching to bicycle. It's a good option to keep social distance to other people. We have the chance to move on. If the fitness centers are closed, I cannot go to sports, but cycling is a good opportunity to stay healthy. We have a demand for new infrastructure, which is not sufficient anymore. So we see this pop-up bike lanes in many cities, Berlin, Hamburg, Paris, and to make the infrastructure better and sustainable in a durable way, we need more cycling data. We also learned that cyclists are very willing to provide their personal data by bicycle sensors, for example, to be part of the projects in citizen science approaches. And our question in the project here was, how can all these newly generated cycling data make available for everyone who's interested, as the citizens, municipalities, traffic experts, also the citizens, to learn more about what is my city, my special city here doing in cycling promotion, and how can it compare to other cities. So our student team did a great job in the last year on the way to making European cycling data available. We got many data sources. Please visit our website, bicycle-data.de. Especially after the BITS Academy. So some of the functions are not online during the academy to avoid that our server breaks down. Many participants here. We considered many use cases as part of the project, as sensor data, environmental sensors from the Netherlands, bicycle apps, counting stations. We have something about traffic safety for you, the near accidents from Antwerp and Zwolle and province of Friesland, bicycle parkings, and we also have the smart helmet for bicycle couriers. We have the University of Bremen prepared a short video for you. And all this data was gathered from different sources and was combined into one database, one platform for the management and analysis of cycling data, including new key KPIs for European cycling data with a visualization component, as you can see below, with the main benefit that these new data could support municipalities on their road or on their path to more bicycle friendliness, as well as traffic experts or software experts working on new smart solutions for cyclists, and of course for the further promotion of the improvement of the bicycle infrastructure. I would like to introduce Kevin Main of Cycling Industries Europe, who will give you some more insights into the BITS project.
Thank you very much, Johannes. The BITS project You can see the graphic on the screen. It shows you a great collection of partners. There are 7 public bodies and 4 partners from the academic and private sectors that are supporting this project, which we think is probably at the moment unique. As far as we know, it's the only international cycling project that combines intelligent transport systems, the ITS part, with cycling. And that tells a bit of a story itself. European Union level, the future of Europe is not only seen to be green, it is seen to be digital. And there is huge future investment plans in these topics of intelligent transport systems. And you will know them through other acronyms. You'll know about autonomous driving. You will know about kind of road safety schemes. You will know about perhaps mobility as a service. And you will have heard of perhaps of national access points. Or in fact, you won't have heard of any of those things because they're just complete kind of EU jargon that is kind of hidden in the background of what we do. But we can assure you that this whole area of the digitalization of mobility is an absolute priority topic. Now, our role as both the BITS project and the Cycling Industries Europe is to ask the question, how does this apply to a 200-year-old technology? How do we make this exciting enough and interesting enough that people who are perhaps fixated on things like autonomous cars actually understand that the digitalization of the bicycle sector has so much to offer? And I know in the registrations for this event today, there were some great companies, some really exciting projects and academic partners who are actually doing a lot in this space. And what we aim to do with the BITS project is to prove in over 30 individual implementations of smart technologies, to launch, as you will hear later, a comprehensive cycle data hub, but then also to provide platforms where the community can meet. And we as CIE provide the kind of industrial and business community, but our academies allow our participating members to host communities of their choice in a setting which is about learning and sharing. We've previously done academies on behavior change and ITS. We've done academies on data sourcing and data types and preparation for the Cycling Data Hub. And I'm really delighted that we have this one today, which focuses really on the work of the student community, University of Oldenburg, and their partners around analyzing data. And I think that's the other really exciting thing for the future of this field, that yes, it's a traditional technology, but here's a group of students, a group of younger people at the beginning of their careers who are excited about cycling data and analysis and projects and the chance to really tell stories about that space. And that excites me as a community that showed this enthusiasm. So what you'll get today will be 3 kind of presentation sections, and each of the presentation sections will be followed by an interactive breakout. And I'm delighted the student community at Oldenburg has agreed they will lead those sessions. It's part of their career development to run a professional event and to have you challenge their research, ask them questions, support them, because this is an important milestone in their careers, that they should do this to a public audience. And with something close to 300 registrations, that's a brilliant audience for a student project presentation. And we are pleased. The quality of the work they've done has been absolutely outstanding. So I think that's enough from the introductory side from myself, just to say, you know, all the BITS contact details are there. Do not hesitate to get back in touch, and we'll remind you again at the end of the presentation. But now let's get straight into it. We're going to hear about the first project, which is the Smart Helmet project. And I'm going to pass back to Johannes to say a few words of introduction on Smart Helmet. But thank you for being with us.
Yeah, thank you, Kevin. So we will start with the Smart Helmet project. It's a project funded by the German Ministry of Transport. It's part of the M-Fund program. So here we will start with a small video, with a short video of the University of Bremen about a study they did at the university. It will be followed by Urban Planger. So Urban Planger is working for UVEX. It's a helmet manufacturer. one of our partners who is responsible for the helmet development in the project, and followed by our student team, which will show you the results, what they was working on in the past 12 months. Harish, can you start to share the video with us?
Yes, sure, Jonas. Thank you. Yeah, now I'm going to share the video.
So this study of the CSL lab is embedded into the research project, Smart Helm, which is targeting on an awareness-sensitive bicycle helmet, supporting bicycle couriers on their working process, integrating many different sensors as EEG, eye tracking, speech recognition. And Urban Planger of UVEX Sports, he will present the first prototype of the helmet to the audience. Can you hear us?
Yes, I'm coming. Hello together. So yeah, if you could make bigger my picture, I would like to show it live on the video. So hello together. My name is Urban Planger from UVEX Sports Group, and I'm responsible for the research department and research projects. And we are responsible in this research project for the implementation of the technical systems and the sensors and electronic systems into a helmet. And due to this work, we already made different prototypes. And Johannes bet me to show the last version of the prototype. As you already saw in the presentation before, we use once EEG sensors to detect the attention of the test drivers, and on the other side we use the augmented reality lens of Microsoft, the Microsoft HoloLens. And this here, as you can see, is the first prototype where we implement the HoloLens. On the back side, you can see the HoloLens as well into a helmet, into a bicycle helmet made by hard shell and EPS dampening shell in the inner side. And now we come to the more, yeah, so to the more, the next step for us is to implement the EEG sensor. And as you see here, as an example, is an EEG sensor with the connector for the electronic system. And in the whole system, we are using 7 sensors at the moment. And in the helmet, we placed seven types of flexible arms where we can position the sensors. And at the moment, yeah, we together with the CSL, we are collaborating and changing prototypes to see how we have to modify the helmet forward, that the signals are coming well to the CSL. And I will show you shortly only yeah, how the test driver can take on the helmet. So I hope you can hear me as well. So it's made so that the test driver can use it as a helmet, as a normal bicycle helmet, and additionally he has the possibility to see through the Microsoft HoloLens, and to the EEG sensors we can detect all the signals we need. So, Johannes?
Okay, yeah, many thanks to Urban Planger great job, very interesting. So the third part of the smart helmet will be the research results of our student group. Can you take over now?
Philo, are you able to present now?
Who's going to share the presentation?
Thilo was going to share the screen because he's doing the introduction part on our smart home presentation.
I don't see him in the, but this, has he dropped out or lost his connection?
Maybe.
Yeah, then maybe Marvin, can you share the slides?
I'll take me a second to find them. Give me a second. Can you see the screen?
You need the
Yes.
full screen.
Yes.
Yes.
Yeah, I was just waiting if you can see the screen. Okay. Well, this is gonna be a little bit awkward now because this is not my part, but I can try to tell you about this part. So in our subterm project, we had some shifting aims. At first, we were focusing on pre-processing, analysis, and visualization of the provided EEG data. Then we tried to create synthetic data based on the data we were provided first. However, we realized that with the amount of data and our current knowledge, this was not really possible. I'm sorry, I forgot to share my camera.
Sorry for the interruption. Marvin, can you also start the presentation?
Wait, can you not see the presentation? It's on my second screen, so you probably cannot see this now. Huh?
So you should switch the screen, I guess.
I just I'm trying to start it again. Can you now see the presentation?
Not in full screen.
Okay, I'll try to share it again. Can you now see the presentation?
Yes.
Looks good.
Okay. So I just told you about our shifting aims because the project is kind of going a little bit slowly because of Corona. There's not a lot of data going on, so we had to work with some lab and whole study data first, and it's not such a big amount of data, but we try to pre-process, analysis, and visualize some of the data and try to create synthetic data. But we realized with the amount of data we had, this was not easily possible. So then we created a database for the Smart Home project, which you can see on the screen right now.
Okay, Marvin, I'm back. Can you hear me?
Yes.
Okay, so I'm now via hotspot because my internet is just gone. So I'm very sorry for that. That was the first time that this has ever happened. Okay, so yeah, I guess Marvin has already basically explained everything on this slide, that we had to shift the focus quite often during the time of our project, or the time that we worked on the Smart Home project in our project. And so, yeah, I think I can already go to the next slide. So yeah, in the first step, we try to work with the EEG lab. That's an extension for MATLAB, and here we try to do the pre-processing. So the assumption was at the beginning of the project that there would be enough data for us available that we could do the whole process of pre-processing, analysis, and visualization of EEG data. And yeah, you've already heard before what the point of all that is, that you're trying to try to figure out through the EEG data whether or not a bicycle driver is distracted on his way. And so the problem was, which had a lot to do with the coronavirus, that the data was just not sufficient, and there was just not enough data. And so we first started off, when we started off our project, there was just no data available. And then after some months, we got laboratory study data. As one can see, the pictures on the right, there was these little videos that the people saw on their screen, where they then had the things happening that were supposed to distract them. And yeah, these distractions are then shown as events in the EEG data. As one can see on the bottom of the screen, these lines, there the event happens, and then the hope is that you can see in the EEG data that this event has happened. And so that later you can just look at the EEG data and tell whether or not an event has happened. And so because there was so few data, so little data available to us, it was decided in the project that we would switch to the synthesizing of EEG data. So you can switch to the next slide. And so the general idea behind creating synthetic data is that if you don't have enough data to do a good analysis of or with your data, you can use your real data to create synthetic data that is close to, but not your actual copied data, basically, so that you can then use this bigger data source to do a data analysis. And of course, I can't go into detail into the synthesization process, but the general idea is that you split your database into two separate groups. And the first real data part goes into a generator, which then creates fake data or synthesized data. And this fake data then gets thrown together with the real data again into a discriminator. And this discriminator is then trying to figure out whether or not the data is real or fake that it sees. And depending on the results, you then fine tune the discriminator and the generator further, so that they both kind of try to get better and better at what they are doing and trying to work against each other. And so in the end, you have synthetic data that is as real as possible. So there was quite a few challenges for us when developing methods for synthesizing EEG data. And the main problem was that synthesizing EEG data is not has not been done that often. There was only a few studies on that, and the general frameworks for synthesizing data cannot just be applied to EEG data. And even for synthesizing new and good EEG data, we did not have enough test data. And so because developing the methods from scratch was very complex anyways, we decided that it would be more satisfactory for us in our project, and it would be a better result if we just used the real data that we did have to try and do the analysis with that data, even though we already knew that maybe that wouldn't give the best results. We thought that it was the better alternative, and in the end, we at least did something with the data that has a certain time of output. And another problem that I haven't even mentioned yet is that, of course, with these EEG data, you have to really keep in mind that you you have to go from data type to data type quite often. And so for our last step, we had decided to just do the whole part of the pre-processing and the analysis both inside of Python, so that we would not have to switch back and forth so much with data types. So basically we cut the EEG lab part that I've talked about before and just try to do everything in Python now. And how we did the pre-processing of the data there will now be presented by Marvin.
Thank you very much, Tilo. I will talk a little bit about the data in general at first. So the EEG data in general consists of the raw EEG data, which is divided into 16 channels, which are recorded at 250 Hertz, which means there's a data point every 4 milliseconds. Every data stamp also comes with a timestamp. Then there's obviously some labels which have some distraction types like visual distraction or auditory distraction, which was explained in the video by the University of Bremen. However, we faced some challenges with the data because the labeling was done at a different sample rate, which means we have around 80 to 90,000 data points for a typical file. However, there's less than 1,000 labels. Also, the timestamps of those labels don't exactly match those data timestamps, so we can't just easily join them. And one more thing is the label events are encoded as bits, but they are stored inside strings alongside some other info, which means we need to extract those label events at first. Our goal was to create basically a huge list of data where every data point has an accurately assigned label. So to achieve this, I can show you the preparation process which we underwent with the data. So the first thing we had to do was we needed to extract the bits from the strings and discard all the other info that was saved in those strings. Then we had to round the timestamps to the precision of 3 decimals because we're working with 250 Hertz, which means we need milliseconds in terms of precision. Then we had to find the closest timestamp in the data from the EEG sensors. And then we had to adjust the timestamps that they match so that we can join those data types together. And because we don't have information until the very first label, we need to fill it up with 000, which basically just means there's nothing special happening, no event. Afterwards, we just fill up everything which does not have a label yet with the previous label. And as a last step, we then save the labels and the data separately again so that we can use those for training for machine learning, which will the other Marvin in our project group now tell you more about.
Thanks, Marvin. After that, we are coming to the analysis of EEG data using machine learning. Our goal was an automatic detection if the user is distracted or not while the user wears the smart helmet and cycles through the city. If the wearer is distracted, it would also be nice to know which is the type of distraction. For that, we trained different machine learning models like support vector machines and artificial neural models like convolutional and recurrent neural networks. Yes. Our next slide, please. Our problem is that none of the machine learning models found a correlation between the data and the distraction types and events. In the table are the results of all machine learning and deep learning models because they are all the same. On the upper part of the table are the detected distraction types by the machine learning models, and on the left-hand side in the table are the real distraction types labeled in the data. For the machine learning models exist 4 different classes. The first one is no distraction, then visual distraction, auditory distraction, and mental rotation task. The same distraction types you have seen in the video of the University of Bremen a few minutes ago. As you can see, all the models detect in every situation that no distraction happened. So sadly, no model ever detected one of the distraction types. Possible problems can be the following one. One reason can be that there's simply no correlation between the measured EEG data and the distraction methods, or the so-called labels. Another problem can be that our machine learning models are just wrong designed and needs a little bit more fine-tuning or more layers for the detection problem. Or we need to add more pre-processing layers, because at the moment we're just using the raw data without any EEG specific pre-processing. Possible pre-processing layers can be a typical low or high level, a low or high pass filter, or to change the time series data to frequency analysis data using, for example, a Fourier transformation, and just use a few special frequencies. And the last problem can be the labeling issue, also mentioned by Marvin a few slides before, and of course, the low amount of data. Yes.
All right, I will tell you a bit about the outlook of this project then, because we imagine in the future we can have some GPS data, like some bicycle trip, which you can see here, with some possible distractions which happened along the way, colored like on a map. Then you can have a map like with full of those trips, so that you can possibly see some distraction hotspots basically around the city. But for this picture, this is just artificial. So the GPS data is real, and also those distractions are real. However, they are not correlated. The trip is just unrelated. We just wanted to show what the future could possibly look like. So now we have an interactive part. For this, we prepared some questions. You can also scan the QR code, and we will put the link into the chat soon. We want you to answer some questions, because we are very excited to hear about your possible ideas for the functionalities and utilizations of a smart helmet, or about the data which could be provided by such a helmet. And we have 3 questions prepared. So we have our first question, which is, what kind of data from a smart helmet would you be interested in, especially in the context of an open data portal? Then how else could a smart helmet be utilized? And as a third question, we have, what info would you want to have on your HoloLens display if you were to drive with such a smart helmet? So I will keep this slide up for a bit, so that you can scan the QR code if this is possible with the quality of the connection. I don't know. Otherwise, we will put the link in the description very soon. And I will share the screen of the so-called Miro board, in which you can fill out some post-its with your ideas for those questions.
Yes, and by the way, at the same time, you may also ask questions. We've already seen some coming into the chat. So yeah, the first question is very much about the helmet. So I think that's better answered by UVix themselves. So at least I wouldn't know.
So I will have to share a different screen now, because I'm just sharing a PowerPoint presentation currently. So that also every guest that is not currently on the website can see how this Miro board looks. Can you see my browser now?
Yes.
Yes.
Okay, so we prepared a very, very simple example because we have a sample idea would be like if you would want to see like a map or anything like navigational details or something on the smart helmet, if you were to use a helmet yourself, you can just simply drag one of those nodes somewhere, and then you can just type into this node whatever your idea or thoughts are about the question. You will now have some time to fill this out or ask some more questions, and then we can talk about a few of those ideas maybe in a few minutes. One of the more practical ideas here is for delivery services to connect to a phone and also help with directions for the delivery service, as well as maybe provide information for the customers. This is what's meant with giving location. This sounds actually quite interesting.
And yes, I can also start a little bit with answering a few questions. What was the frequency of your eye tracking? At the moment, we don't have analyzed the eye tracking data. It's just the EEG data. And yes, we don't have the eye tracking data, so we have nothing done with that. Machine learning is about bias detection and bias optimizing. Yes, but with that we haven't that much time to delete any bias, and it's just we need more time with the data to eliminate every biases, and that could also be a big problem. And yeah, you're completely right.
In the interest of time, Marvin and Marvin, I think we're going to have to wrap this session in a moment and move to the next one to give your next colleagues time on there. It might be good if you could answer the questions in the chat as we go along as a group, and then we'll move to the next session.
Yes,
and we can perhaps come, if you see some good conclusions, we'll use them at the end of the session.
Okay, yeah, I apologize again for the technical hiccups, because this just was quite unexpected, but I hope this didn't impact our presentation too much for you. So thank you again for your attention.
Yeah, excellent job. It's a fascinating project, absolutely fascinating. Thank you for sharing and for taking us through that. We're now going to move to the session which is on data types, data formats, and the added value of bringing data sets together. But don't hesitate to keep asking questions in the chat to the previous group if you want to follow that through. And obviously you better reach out to both the company and the students after this session if you need to. But I can pass to Anselm, who's going to take us now through the session on data.
Thank you, Kevin. Just start sharing my screen. Can you see this presentation?
Yes.
Yes.
Perfect.
Yes.
Then welcome to the second part of our presentation. In this part, we show you with what kind of data we dealt over the last year, which data we made available on the website. There are 5 different types of data, and in the next slide, we show you how what these 5 types of data are, how they work, from which cities we have them, what problems we had to unify them, and at the end we have a small interactive part in which we brainstorm what additional data would be interesting to get more results from our data and what kind of analysis would be interesting. So we start with the first type of data, that's the simple bicycle counting data. Here we have a bicycle counting station somewhere placed that measures how many bicycles pass the station in a certain time interval. We have this data from 32 regions in 3 different countries, and overall we have 201 counting stations in our database. So on the map you see an example for Oldenburg where the different counting stations are distributed over the city. Here's a list from all regions that we have. As you can see, the most of them are in Germany, but a few internationals, and hopefully there will come a lot more internationals in the future. Every one of these stations of these regions had a kind of different format. So most are similar, but they have, for example, some of them measure just the total amount of bicycles. Others are able to distinguish in which direction the bicycles drive, and so most of them measure in a 15-minute time interval. The others, some of them in a 60-minute time interval, and even if they measure exactly the same, they just have different format in the raw data, maybe different date format or something like this. So we had to think of a format that we can unify them all together. Therefore, we decided to use the datex2 format, where we have a timestamp for the start and the end of the interval. So if we have a 15-minute interval, then these 2 timestamps are 15 minutes apart of each other. Then we have the count from and count true for the both directions if they are available, and both directions for the total amounts of the bicycles. And we enrich this data with some additional information about, for example, the location of the counting station, in which country it is, in which region, and the longitude and the latitude, about the weather conditions that we're doing the time interval, so the temperature, the wind speed, precipitation, humidity, and a lot more, and information if on the day where the bicycle has driven was a public holiday in the country or not. There are probably a lot of more things that are interesting to know, but that's a question that we then will have a look at in the interactive part, what other things could be interesting to know about the counting station. And now I pass to Franziska, who tells you something about near accidents.
Yeah, thanks, Anselm. I will tell you something about the near accidents, but first of all, what are near accidents? Near accidents are events that don't result in injury or damage, but the potentially could. Yes, on our map you see one crossing. It's a crossing in the province of Antwerp. The bicycles are very colorful because we categorize the near accidents data in 4 risk class. For example, the green bicycles are low risk and the red are critical risk. All we have 3 data from 3 regions and 2 countries. Next slide, please. We have data from the province of Antwerp. There are only 1 crossing, and we have 2 crossings or data from 2 crossings of the province of Friesland and 2 from Zwolle. So 3 different regions mean different data schemas. We convert the different schemas into a uniform schema in our database. For this, we picked out some coordinates from some crossings, and we generate a date for some datas, because we have only time and no date by some datas. For the coordinates and for the data generation, we use the supplied PDFs from the province of Friesland and Zwolle. And now I will tell you something about the parking data. In the case of bicycle parking, data on the utilization of bicycle parking facilities was collected with help of sensors. On the picture, you can see the positions of the bicycle parking facilities of Utrecht. We have only data from the province Utrecht, and therefore, unfortunately, no other data with which we can compare it. Therefore, we adopt the schema 1-to-1 in our database. And what else we striking about the data is that we generally have minimum and maximum values, but not total values. That's a little bit, yes, it's not so great. And with that, I head over to Dennis.
Yeah, thank you, Franziska. I'm now going to explain the type of data we're working with regarding Snifferbike and the bicycle app. Firstly, Snifferbike is a project taking place in the province of Utrecht and Zwolle. They collect data about the air quality in those regions while also tracking the driving behavior of the participants. I brought a picture of such a sensor so everyone gets an idea how this works. So it is attached to the front of the handle of the bicycle, so it can take in the air while driving and measure the quality. On the next slide, I want to show you an example of a visualization of the Snifferbike data, so we get a gist of what kind of data we're dealing with. On this map, we can see a heat map of the measured particulate matter, PM2.5, in the city of Utrecht. And you can easily see where the air quality is lowest and in contrast where it is a bit better. Lastly, I want to talk about the data format of the Snifferbike raw data we're working with. We can see that the data we're given already consists of quite useful information, like the different particulate matter units and the location. But for the sake of statistics and KPIs, we wanted to also calculate information about the distance, duration, and average speed of the different trips that were recorded. This is why we created another database table connected with a unique trip ID, which we can see on the right side. The raw data already had an attribute to differentiate between trips, but because they were reset every week or so and therefore weren't unique IDs, we created our own. Very similar to the Snifferbike data is the bicycle app data that we're working with. The app is called Cycle Green and consists of an online platform combining a web app and a smartphone app. The participants measure the bike rides regarding location and time with the smartphone app and submit the data on the web platform where it is put together with the data of other participants from the same city, province, or region. At the moment, we only have this data from Oldenburg, but others may follow in the future. And more information about the app itself can be found on the website. And I think there are also some representatives present for this event today. So maybe they can answer questions if there are any. The difference between this data and the Snifferbike data is obviously that no air quality is measured, but regarding the formatting in the database, we handle them very similar. As you can see, the raw data also consists of individual coordinates and timestamps, which is why we decided to generate a separate trips table for the bicycle app as well. For Snifferbike, as well as the bicycle app, we didn't have to generalize or reformat the data much, because in both cases, we have just one origin of data, so the format is already the same for each data set. More information about the analysis and calculation of the KPIs is provided later on when we see the live demo of the website. So that was all regarding the different types of data we are currently working with. I now pass the word back to Anselm, who is going to explain the next interactive session of the event.
Thank you, Dennis. And the interactive part, we will use Miro again. We have, but a different board this time. On this one, we have 2 questions. The first one is what additional information could enrich the raw data? We have already seen we have the information about the location, like the longitude and latitude, and the weather conditions and the public holidays. But there probably can be a lot of other things that are interesting. And if you already know how this information could be accessed, please let us know as well. And the second question is, how could the data be analyzed? Which KPIs could be interesting? So we have, I will send you the link to the pad in the chat. And we have this, here are our 2 questions. You can just grab the sticky pads in the middle. And for example, if we have here what additional information could enrich the raw data, could, for example, say, okay, bicycle count would be interesting. What is the population of the city? And then just double click on the pad and start writing on it. And for in the second questions, we have what could be interesting. There could be, for example, if you want to know what weekday are the most bicycles driving, or what is the average speed of near accidents vehicles, or something like this. And if you have any other recommendations that don't match the 2 questions, we also have a little bit of space here. I think we have 10 minutes time on this one, and doing your work on this, we start to answer your questions from the chat. Where does it start? Okay, I think the first question was on the risk class to the near accidents. There's, I think, some of the crossings, intersections calculate the risk classes, others not. So we just looked at how they're calculated in the intersections that do it. It's a mixture between time to collision and the speed of the vehicles. And for the intersections that don't calculate them, we just calculate them in the same way. So we are able to compare between the different calculations from different locations at the different intersections. And do you only consider accidents between bicycles and cars, or also bicycles, bikes, pedestrians? I think we consider both. At least one bicycle has to be in the accident, but if the other part is a car or a bike, we consider both of them. And the data also includes tourists, as we are not able to distinguish which one was measured. We just can measure if someone is on a bike or not. So of course, it also includes tourists as well as locals. And if anyone asks what we do with the results of these interactive parts, of course, we can export them as PDF and send you them as email, but we also keep working on it. There will be a few of us keep working on the project even after the project group ends, and there are future project groups. So the results that we from this interactive part, we use them to have a look at what we can, how we still can improve our website. So.
Anselm, you have one new question in the chat. How many weather parameters do you use, and where is the weather data provided
Okay,
from?
yes, the weather data is from the Visual Crossing Weather API. But I just can, maybe someone has a link to the weather API from our project group and can post it in the chat. And there are a lot of things like snow depths and some of them, but we don't always have reliable data and all of things that they measure. The ones that I told before were temperature, precipitation, humidity, and wind speed. We always have this one. There we have them for all cities and some, yes, a lot of a big list of other things. Unfortunately, we are not able to allow them at in the raw data downloads that you will see later on, because we don't have the rights on them. So we can just use them for the analysis where we analyze the data, but just don't give them as the raw data directly. Okay, it's 10 past. Kevin, do you want, think that's the time slot that we had? Do you want to have the break now?
Do you want to summarize anything from the Miro board, or are you happy with, you've had a lot of content?
I had to look at it and I'm really happy about this. I think it takes a lot of time if we would go through every of these notes, but I already seen plenty of nice ideas, like having the quality of the roads for bicycle count, or contrast how many bicycles are going in compared to cars, for example, and others. So there are a lot of great ideas. I'm really thankful for all of them.
I think it's going to be interesting for the KPIs. I've seen some that we already calculated. So in the live demo, many of them will be seen that we already did. So that's going to be interesting, I guess.
Good. Well, thank you to you both, to the team, for this session on data. I mean, you can see how excited people got with this one by the amount of activity on the Miro board. It's like a swarm of wasps from where I'm looking. So that's really good, and obviously we get value from what you've done, and hopefully you get value from this feedback. Okay, everyone, we're going to take a short break now because it's a long time to concentrate on these Zoom sessions. You can of course leave the link up and leave the thing running, but we are now showing 11 minutes past 3 on my computer. We will return at 20 past, so you've got time to grab a quick tea, coffee, comfort break, and we'll return for quite a kind of a dive down into the data tool that's been used, and we'll also hear more about the Cycling Data Hub from the BIDS project before we kind of wrap a bit later on. So prepare yourselves, and see you back here in about 8 minutes. Thanks everyone, and thanks to the team. The first 2 presentations, absolutely excellent. Thank you very much.
Thank you.
Thank you for your listening.
Oh, thank you to all. Great job.
Yes, thanks.
Welcome back, everyone. Delighted to see 160 people that have stayed on this on the call. I hope you will take a moment to refresh. This next session is one we've been looking forward to for a while and allows you to get even more interactive. What we're going to do here is have a presentation on the data portal that the University of Oldenburg team have built and they're going to show you about how that portal works and some of the kind of KPIs and analysis in that data portal. But what we want to do after that is then invite you into breakout sessions, and you will be prompted by the Zoom tool to actually take a choice of any one of 4 breakout sessions where the team will invite you to kind of dive much more deeply into the data and to actually choose to analyze the data portal for the type of data sets you're interested in. One session will be dedicated in German, one will be German English, and 2 of them will be in English, and you'll be able to see that from the invitations that come up, and you'll get a brief description on your screen. If anybody doesn't join one of those sessions, then my colleague Johannes and I will stay in this main thing. We can have a discussion of other topics, but we really would like everybody, preferably, to dive into one of those sessions so you can really see this very interesting data portal in action, because I think that's one of the most important learnings from today's session. So I'm delighted to invite Jan from the team, who's going to kick off the presentation on the data portal. Over to you, Jan.
Okay, thank you, Kevin. So as he mentioned before, our presentation team wants to show you our main product we've been working on for the last year, our website. And in that case, we want to show you our current process at first. It's quite adventurous, so let me explain. The first thing we got is we got most of our data in the form of CSV or Excel files. We used these files and integrated them into our Python project. We are using PyCharm as a development distribution for it. And we are using the MariaDB database in order to store all the data. So we made a big data hub where we integrated all the data coming from all over Europe to integrate it in one big database. Then we created an API, which I will come to on the next page, which we are using to forward the data to our website, which is behind the reverse proxy. And on our website, we are mostly using different JS libraries in order to make graphs or be able to give you the raw data over our open data portal. The next part I want to talk about is the API. We were using a combination of the Flask and Waitress. We made a RESTful API, meaning we used GET and POST requests in order to get the data from the database to our website. And Waitress is a library which is used in Python to queue all the requests we are getting from our users to be able to distribute the website to the whole world, basically. In order to do that, we established different endpoints. One of them, and the most important one, will be the visualization, which we will show you in the live demo afterwards. The other one is the Open Data Portal. The Open Data Portal was the first task we accomplished, where you can download all the raw data we have collected in the last year to use it for yourself. I will show you that later. And the last thing we made were different KPIs, which I hope you all know, key performance indicators, which we are using to determine the most important statistics we have found so far on our website. We can go on to the next page.
Okay, I hope you can hear me and hopefully see me. My PC is loading. Okay, thanks, Jan. I will introduce you to our website now. We have basically 2 main parts on our website. We've got the visualization part and the open data portal. The first functionality on our visualization part is the city comparison. There you can compare different cities to each other based on some KPIs. If you want to have a closer look onto one city, you can just use our own built city analysis. There you have got an overview on the map where you can see the different positions of the measurement points, or how we call it, the stations. Furthermore, you have got a lot of different KPIs regarding to one city. The last functionality is the graphical representation. There you can create different bar charts where you can, for example, see the total amount of bicycles which were ridden in 1 week in Oldenburg. But we will show you these later in our breakout sessions. The second part is the open data portal. Like Ansem has showed before, we've got a lot of data which we harmonized and uploaded into our own database. The open data portal offers you the possibility to download the raw data in different formats. We've got CSV and JSON, but you don't even really need to use our open data portal. It makes it more easy and more understandable for normal users, but you can just generate a web link where you can take the link, type it in your browser, and just communicate directly with our own API. And for programming, we use different JS libraries. For the symbols and the fonts, we used font awesome. For the map, we used Leaflet, and for the different charts, we used Chart.js. To make the website look more modern, we implemented the common JS library Bootstrap. So all different input fields, like the drop-down fields you will see, are from Bootstrap. And of course, we use the most common JavaScript library, jQuery. jQuery offers you a lot of functionalities just to create more effective code and make it look more clearly. So I would say we can now start with our live presentation, and I would say Tuba will start now.
Thank you, Simon. Can you see the website?
Yes.
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 So I would like to tell you something about our city comparison page. The page is tasked to compare different cities, provinces, or data sets with similar characteristics. When the page opens or a new box generates, the KPIs for counting data and Brügge are automatically calculated and displayed, since they are the first choices in the drop-down menus. Currently, the following different data sets are available: counting data, parking data, near accidents, sniffer bike, and bicycle apps. Depending on the chosen option in the first drop-down menu, the locations belonging to the data sets are automatically read from the database into the second drop-down menu. And by clicking on the plus button, you can always add more boxes. And for example, you could select counting data in the first one and Oldenburg in the second one. The 4 fixed KPIs will be calculated and displayed in a few seconds. Now you can see here the results, and you can compare the different cities, provinces, or data sets with each other. If you don't need a box anymore, you can close a box by using the X button on the upper right corner. And now René will tell you something about our city analysis page.
Yes, thank you, Tuba. Can you see the website?
Yes.
Yeah, this is our city analysis page, where you can analyze the city more closely, or sometimes regions, because we have a few provinces in our data set. As you can see there, the structure is pretty simply pretty the same as the city comparison page and also as the graphical representation page that Simon will present. As first, we select again the kind of data set. So I will start with counting data, and afterwards there again is filled the cities and the stations. Yeah, I will pick one with a few more stations. So for example, Oldenburg. So then we can see on the map Oldenburg with all these stations. And if I select a single station, then it will zoom in on the selected station. And it's also relevant for the KPIs, which will be calculated, but I will explain that later on. For the moment, let's just stay with the map. We have a few different visualizations on a map depending on the data type. For parking data, it's pretty much the same as for the counting data. We just see the different locations on Utrecht for the different parking garages. And the accidents, that's the picture you already saw in the previous presentation. So this is Antwerp, and you can see the difference in the accidents categorized with the risk categories. So green are the lowest and the red ones were quite critical. And you can also change the map interface, so then you can see the satellite and can see more closely where exactly on the street was in the accident, for example. Yeah, then we also have the bicycle app. This will take a few seconds, but when it's finished loading, you can see the different trips of the bicycle apps, and each color will be representing a different trip. So yeah, there it is. And so you can analyze which streets are cycled very often and which not that often. It has to be said that if you click on the info button here in the corner, you can see that for the sniffer bike heat map, I will show you afterwards. And for the bicycle app trip map, the amount of data we use is limited. That's simply because we can't load all the data into the map.
Benny, sorry for the disruption, but the screen is really blurred, maybe because of your internet connection. So we don't really see any of the KPIs.
Yeah, there's
so
a
maybe
problem with solution.
another one can share the screen and you just talk. Maybe that works.
Yeah, Simon, can you maybe share your screen, or Tuba? I don't know.
Moment, ich muss kurz raussuchen.
So now it's better.
Yes, thank you, Simon. Then please select the bicycle app. Yes, as I said, you can see the trips right after it's loaded. And yeah, the amount of data is limited because otherwise our infrastructure cannot load all the data. Yeah, there it is. And yeah, as I said, each color represents a different trip, and but you can also see that the start time and the end time select boxes on the bottom of the map also is dynamically filled with the first and the last timestamp. The last kind of data set, Simon, can you please select sniffer bike? Yeah, this will generate a heat map with a particular matter 2.5 values now of the province Utrecht. So you can then see where the air quality is best and where not so great. Yes. Yeah, it looks like it's all red and all very high, but it's only because the type of map will add all the values together if you zoom too much out. And if we zoom more in, we see that there's in between not so high points. Yeah, then maybe check to Zwolle and then calculate the KPIs, please.
I think we get an echo from Johannes because it's not muted, if I'm not incorrect.
Yeah, and yeah, calculate. It's now loading the KPIs. So afterwards, you will see a table where all the KPIs are shown. We only will show one example, but in the interactive part after our live presentation, in the breakout rooms, you can ask us to analyze specific data sets, and we will then explain the KPIs. Yeah, here you can just see it, the KPIs for the sniffer bike data set. So we categorized each trip and weather classification and calculated a few different KPIs for them. And now I pass to Simon for the graphical representation.
So thanks, René. Hopefully you can hear me now. Now I will show you our graphical representation. Like you've seen before, we differentiate between different kind of data. So for this example, I will just choose counting data. After I've chosen counting data, the drop-down field of the different towns will automatically get filled. So now you can see that we've got a lot of different towns in our database. For this example, I just will take Dortmund. And after these, I can just choose which type of graph I want to analyze. So we've got 4 different kind of graphs. We can compare different cities to each other. We can compare stations. We can see an average week on average day. For this example now, I will just take average week. But like I said before, we will do more examples in our breakout sessions. After this, I can choose which attribute I want to analyze here or to show here. I want to see the total amount of bicycles which were ridden in Darmstadt in an average week. So maybe you've seen the timestamps get automatically filled. So the first timestamp shows the first data set we got in our database, and the second one shows last timestamp of our last data set in our database. Now you can say, okay, maybe you only want to include weekdays, or you only want to include weekends, but for now I want to see all days. And to trigger the event, so to draw the graph, I just need to press onto the draw button. So it's quite fast. You can see at the top of, okay, I don't know if you see these two, but do you see the circle too on my screen?
We see it.
Yes.
But who did this? Somebody used the Zoom function, I think. Okay. At the top of the screen, you can see we got average and total values. If you want to see total values too, you just need to press onto it. But for now, I want to analyze the average values. So when I hover above Monday, you can see the explicit value on a Monday. So you can say 1,057 people drove an average on a Monday. You can do this for every day, like ever what you want. For now, we would say it's enough. We will see much more examples in our breakout sessions, but now I would say, Jan, it's your turn to show the next functionality.
Thank you, Simon. I will take over the controls. Can everybody see my screen?
Yes.
Yes.
Okay, so some of you may know it already, but this is our open data portal. Here you are able to download all the raw data we have been collecting. It's all privatized data, so we didn't take sensible data into it, and I just want to show you how the process is working and how you can interact with the site at all. The first thing you do is you choose which kind of data you want. For this example, I want to show you the counting data, and we'll take some data from Berlin. The first thing we have to do now is wait a short time, because it now calculates which is the time span in which we can find data. So we found data from the 1st of January 2017 until the 13th of June 2020. But because this is a way too big time span, I will adjust it to just 2 months. The next thing you can do is you can select all locations, so every station in the city, or you can select only the stations you're interested in. I will take these 4, and then you can choose all the attributes you want to use. So I will take all the bicycle data info, I will take the latitudes and longitudes of the station, and I will take the weather classification for this process. The last step you can do is you can choose the data format. Right now we are using CSV or JSON data. I will take the CSV for now. And I want to explain to you what these buttons are doing before I'm generating the data. So the first one is the legal notes. There you can see all the licenses we took from the different places we collected the data from. The second one is the preview. The preview shows you which attributes you have selected, and like a preview basically, so you don't have to download the data before to see the table. Then you can click on generate data, which is the main point of this portal. And in this case, it went really fast because I just used 2 months. Okay. So when I'm clicking it, it generates the data directly. I can show you here as well. I use the same thing. This is using some more time. And then you can see the CSV data. I'm using Excel for now, and you can see all the data. You can do this with every data we have. I can show you in the breakout room some more examples of it, but because of the time, I don't want to go through every table. We can do it in the breakout room in the last. But the last thing I want to show you is the generate link option, where you will be able to get a link you can use, for example, on your website or something. You can just use the link to get the data directly and to fast forward it to your users as well. So you can prepare the links on our website and then use it into your own onto your own website for further use of the data. So this was the live demo of the open data portal. If you have any questions, you can ask them now, or we can go to the breakout room and talk about the data as well.
Thank you, Anne. That's excellent. Let's just see, are there any immediate questions in the chat for the result of the presentation that we can all take?
René, we have the same problem. We can't see the slides on your PC. Can you maybe turn off your camera so we can see them?
Yeah, of
when we're in the breakout rooms. Maybe it's fixing the problem.
Better now, or?
At least we can read it now. Thank you.
Okay. Yeah, we prepared 4 breakout rooms for you now for the interactive part. So the first breakout room is for the bicycle counting data. So we will provide you there with more information about the counting data and the parking data. This room will mainly be in German because most of our data is from Germany. But if you don't understand German and also have interest in these kind of data, of course, we will answer your questions in English. Then we have a second room for tracking or sensor data that will focus mainly on sniffer bike and bicycle app. This will be completely in English. Then we will have another breakout room for traffic safety data, so the near accidents. This will also be completely in English. And then we have a room for the technological background. This will be in German and in English, depending on the questions. And there we will tell you something about the use technology the technology we use, the different libraries where we use to program our code and our technological infrastructure.
I hope that's clear to everyone, so that we're happy now to trigger the breakouts. And you say you really do get to see this live. You can ask the students to demo in detail, to find you a data set, and to just experiment on how that works for your questions, so that make it as interactive as possible. And we have allocated quite a good length of time for this. So you've got 20 minutes, so everybody can dive in and ask questions. If for any reason you're not in the right breakout room, then you click leave the breakout room, and you'll come back to this main space, and you could be reallocated to a different breakout room. We will keep this main session open for anybody that's here, but hopefully everybody will disappear to a breakout. I'm going to ask.
Let me just add, yeah, Kevin, hi. Let me just add one thing. So now I'm gonna open the breakout rooms. You will receive a pop-up with a notification, and you will be able to choose in which room you would like to be assigned. In case you get into any troubles, please let me know in the chat, and I can also assign it from the controller. So rooms are open.
Welcome back, everyone. Good to have you all back at the central point of the call. I hope the workshops went well. Everybody's had a chance to have a good look at the data tool, and I hope the student team have had some good feedback on your work. Good. Our closing session now is just to bring you in another place in the BITS project, which is to introduce the Cycling Data Hub. Now, this session has been very much about data analysis and about taking data sets and using them and analyzing them and those kind of tools. Separately, the BITS project is supporting the Cycling Data Hub, which is an international open data portal, which enables cycling data sets to be made available and to be contributed from both our project partners, but from the wider world. We've identified at the European level through the work of CIE that cycling data sets are very poorly available in, for example, national access points for data. And the Cycling Data Hub is planned to be one of the most comprehensive resource sites for data sets in cycling. It's just gone public. We had the press release today to make the Data Hub now available for people to look at and to use. And I'm delighted to invite Kim Verbeek from the project team at Province of Antwerp, who have been managing the Cycle Data Hub, to just give us a kind of 10-minute update on the hub, what it does and what it could do for you. So Kim, welcome.
Thank you. I hope you can hear me all and see my presentation.
We can indeed.
Okay, thank you. So my name is Kim Verbeek. I work with the province of Antwerp as a GIS data analyst, and I proudly present you the Cycle Data Hub. It has been a challenging job, but we are very happy that it is gone live today. So what is the Cycle Data Hub? As Kevin mentioned already, it is a central place or a hub, you can name it a catalog for finding bicycle data. It is not so much a data storage tool. It is a place where we collect the data links. So the data remains with the data owner, but we don't store the data on itself. It is based on ArcGIS technology, but it doesn't mean that you need ArcGIS online accounts to contribute data or to discover the data. It is available for everybody. The main aims of the Cycle Data Hub is to give cycle data more visibility, because now it is often hidden for in-house research or something for innovation. But by making it more visible, we want to enable the innovational technologies and give research groups like Oldenburg the opportunity to retrieve more cycle data. Also, by combining all these types of data set and showing the variety in different data formats, we hope we can be an enabler in standardization. You can access the Cycle Data Hub via this web link. You get a presentation later on, so you don't have to memorize it, but I think it's pretty easy. For who is the Cycle Data Hub, or which data can you find in it? First of all, the BITS partners who did pilots, they can share their results, their data in the hub, but also their historical data. For all of you experts, providers of technology who have a lot of cycling data available, we would be very happy if you contributed your data to the Cycle Data Hub. And regarding the users, it is, as I mentioned earlier, for everybody. So you don't need a particular account or something like that. There is only one requirement if you want to contribute your data. You should make your data available on a web link. If you have ArcGIS online, then it is very easy. Then you can contribute very easily. If you have a website where you store your data, it is nice if you give extra information on your data set. It will get clearer as we look at the live version in a minute. When we collect data, it is necessary to keep in account the rules to GDPR. So therefore, we will not collect data which has privacy sensitive information in it. It is a responsibility of the data contributor to approve our disclaimer, therefore. And then also to make data findable, we need tags. As we will see in a minute, there is not so much data in the Cycle Data Hub at this point, but I am confident that after this academy, a lot of you will be interested in sharing your cycle data. And if we have a lot of data, then it is really necessary to use the right tags to give users the ability to find immediately what they are looking for. So now I'm going to show you the Cycle Data Hub itself. Normally it should open in a few seconds. So this is the Cycle Data Hub. As you can see at this point, we have 7 data sets added to the hub. There are 3 ways in which you can search the data in this hub. Via the search button, you can type any keyword and see what that gives as a result. I'm pretty sure if you type cycle that you get some results. For example, the salt gritting routes from the municipality Zwolle. Since they added their data from ArcGIS Online, it looks like this. You can easily see which attributes is in the data. You can look at the data itself. You can use the API Explorer, or if you like old school downloading options, then you can choose from a variety of data formats. You can also make a web map instantly from this data and add your own information to it. To go back to the main page, you can click on the name Cycle Data Hub. And then we go back. We also have these 6 themes or categories. They were agreed upon in the work group for BITS. these are the themes we work on with our pilots. For example, if you are particularly interested in data regarding environment emissions, then you can simply click this button, and then you see that we have here the data from Sniffer Bike. Then also we have the web map, which gives you a quick overview in where the data is, or which regions the data shows. You can click on them, and then you can immediately go to the page which shows you the data. You can filter it by clicking on the chart. So here we see the data set from Zwolle. And if you click again, then you see all the data sets. At this point, we don't have data yet regarding personal health or safety or bicycle business performance. And that's the reason why it doesn't show up here in the options. Now, this is for how can you discover the data, but we need more data links. So now we talk about how you can contribute. If you have an ArcGIS online account, then you can either click on this button, and via a survey, you will be invited to the content group. But you can also search for the content group, which is here in the ArcGIS online environment, for Content Cycle Data Hub. It shows you, it gives you a good description in how you should tag your data to make it findable in the hub, and that it is important that you put the sharing level to public. Simply click on this button to send us an invite, and then we will add you to the content group, and you can share your data yourself. Now, there is no reason to panic if you have data but no ArcGIS online account, because you can also add the data through this button. It opens a survey. We should wait a while, yes. So first, this is now in Dutch, but if you have if you speak English, then it will automatically detect in which language your computer would prefer to show the survey. So here I say, yes, I am going to share data, but it doesn't contain privacy sensitive data. Here we say what we do with your email address. We will take good care of it and don't put it somewhere. Then you just fill in a bit of information about who you are, your email address. Are you a BITS partner? It's not necessary, of course, because everybody can contribute data. Name of your organization. I'm just going to fill in test to speed it up a bit. Type of organization. You should give your data link a name. You can give also a description if you like, and you can point out which region your data is about. Here you should put the web link itself. For this test, I'm going to use simply our application FITS barometer, cycle barometer, like this. And then you will be guided through several types of tags, like my data set has data in it on cycle use, on cycle infrastructure, but has also data on safety. Then you can see a bunch of optional tags. So they are not mandatory, but we highly recommend to be as specific as you can, because it will improve the searchability or the options to discover the data in the hub. You can also say what the aim of the data collection was. For us, it is the reliability of the infrastructure and the comfort in using it. And you can also say if there are other types of vehicles included in the data sets than cyclists. What types of formats is your data in, like OEMS? And how is it collected? Did you use a camera, an app, some sort of counting system? And is there a type of license needed to access the data? I'm not going to click on the send button, but what happens is you will be informed that we got every information that we needed, and we will validate your data set, and then in a few days it will it will get visible in the Cycle Data Hub. So I think I said everything about the hub itself. I'm going back to my presentation. If there are any questions, you can ask them in the chat or contact us at bits@provincieantwerpen.be. So we have, to finish the presentation, 2 calls for you. The first one is, as I mentioned before, I think, please link your cycle data to the Cycle Data Hub. And the other one is something new. We have a new framework agreement at the province of Antwerp, where we are looking for providers of all kinds of technologies regarding traffic research, cycle use, traffic safety, detection systems. And there is now an e-tender available via this link. You can also find us on LinkedIn. And if you have something to offer in these technologies, please contact us and look at the e-tender, because we are very interested in more cycle data. So I thank you for your attention, and if there are any questions, please ask them.
Thank you, Kim. We've got a few minutes left. We're going to do a summary. I'm sure I see numbers are dropping slightly. I'm sure other people there, but I'm sure we can take a quick question or two in the chat if you've got them, and Kim can always answer them while we're wrapping up.
Yeah.
Anybody got anything immediate or burning that they want to pop in the chat? No. Okay. Well, Kim is there. The contact details are there. I'm sure many people from the corporate sector was very excited when they see there's a tender going, Kim. So I'm sure you'll get some responses to that.
I hope
from people
so.
who've got services to provide. Good. I think, conscious of time, conscious of numbers, they're actually diminishing on the call now. I think firstly, I'll just ask. There's about a question about the BITS project from Danny Woolard, which I'll come around to in a moment, perhaps. Johannes, would you like to perhaps give a closing word from the Oldenburg side, and then I'll say just a few closing words from the BITS project side.
Yeah, thank you all for participating. We are still more than 100 people. I think there was quite a lot of interest, and parallelly I got some interesting email, so it is a good opportunity to further exchange. I think the most people we have to thank are the students. They did a very great job in the past 12 months, so thank you to the group. And we are looking forward to further cooperate with you all.
Thank you, Johannes. I can't help but echo that, and it reflects what I said at the start of the meeting, which is to have a group of students putting this amount of energy into cycling data and into this kind of concept area of cycling is really exciting for me, and I know for many people in our community, and probably the feeling that it's long overdue that cycling began to get this kind of attention. So both from the whole BITS project side and personally, my congratulations to University of Oldenburg for giving this space and this platform for the students to perform, and well done to you all. I hope you find the process valuable, and that you got some really valuable feedback to all of you, and good work. Just to conclude the overall kind of process, and perhaps say to, I think it was a question about follow-on plans for BITS. The BITS project still has nearly a year to run. So there is still work there. We are talking to our funders about an extension of that project. But this group and this experience is allowing us to collaborate on numerous fronts. And as I said at the beginning, there is a real excitement on bits and the bicycles and ITS, and where we feel we've maybe been neglected by the kind of motoring community and the policy community in the historic period. Now we are really, I think, making our way, and we're finally part of the recognized EU stakeholder community on ITS. And that will lead to further opportunities, whether it be Horizon Europe, whether it be the EIT Urban Innovation. If you're into that kind of EIT Urban Innovation, actually has an open call for urban innovations right now for cities and companies and other participants. So do not hesitate to look at EIT Urban Mobility if you're actually wanting to put your project and bring it to life. What you can do now, number one, is you can go and look at the BITS project on our website, and you can sign up for our newsletters. That will tell you about the forthcoming academies. That will keep you in touch with the different elements of the project. That will enable you to contact the partners individually and follow up work with them about what's going on. What is to come? Yes, we will be planning some more academies, so on other topics. So watch this space. Secondly, particularly for those of you with a solution that you're excited to share, maybe to share and have analyzed or see used in cities, we will be publishing a state-of-the-art products and services directory in which we're building at the moment, and we'll probably go live in a couple of months' time, where any contributor, so you've seen how you can share your data, but you may want to share just your excitement about your product and service, and that'll be coming and be hosted by Cycling Industries Europe. So we will have data, but we'll also have solutions visible in our project. And then if you really want to deep dive, particularly in the corporate sector, we have 3 expert groups running that actually work in this space. We have an expert group on cycling and ITS, but we also have an expert group on intelligence and market intelligence for the cycling sector in partnership with European Cyclists Federation. And we have other expert groups working in this space. We have just launched a cycling innovation network, which has a group of companies, particularly startups and innovators, that are interested in how you bring data and innovation together with the marketplace and potentially meet investors and funding streams. So if you're interested in that side of the process, you reach out to Cycling Industries Europe and our colleagues, and we'll talk about how you can join our expert groups. So you can be a follower, but you can be a participant. And I think you've seen from Kim, you've seen from Johannes, you heard from us that you can get involved with the BITS project and its partners in many different ways, depending on which sector you're from. If your overall interest is policy, there's a European level policy event on 22nd of April where we really talk about where cycling is going next. Don't hesitate to follow that to hear from some of the kind of leading participants in this space. So a lot happening, a lot of opportunities. Thank you for the very positive comments I can see coming in the chat. And we look forward to having you with us in many different forums and many different platforms. And I close by saying again, congratulations, Johannes, for your leadership in the team, and to all of your student colleagues for the excellent workshop today. University of Oldenburg for providing this opportunity for all of us. Thank you, everyone, and have a good rest of the day.
Please don't forget to test the website and send it.
Sorry, I should always say that. There's so many things you can do to follow this webinar.